Hi, my name is Nasmin, and this is the project I've been working on, the Unforgettable Cube project. The aim of this project is to build a 2x2 Rubik's Cube prototype fitted with tactile sensors. These were the main functionalities I aim to achieve by the end of the project. Firstly, the cube should light up each tile through the use of LEDs to produce a visible pattern. Secondly, the cube should take in the user input by detecting each press with the help of tactile sensors, which measure the changing magnetic field between the magnet encasing the tile and the Hall effect sensor inside the cube circuitry. Finally, on one face of the cube, a display should be fitted that shows the current score. Here's a simple diagram that shows how I envision the cube to look like at the beginning of the project. As you can see, one face of the cube has tactile sensors with RGB LEDs underneath. Another face has a display that shows the scores. In order to achieve the project aims, I divide the functionalities in two sections: fundamental requirements and supplementary requirements. So, for the fundamental requirements, which were the basic requirements in order for the cube to work, were as follows. The cube needs to be able to detect button presses, light up each tile for at least 1 second so the user can see the pattern, make sure the system remembers the pattern so you can compare it with the user input sequence, and detect when the wrong tile has been pressed. Then, when or if these requirements are met, these additional requirements are added, which were display the score every time the game ends to provide a feedback to the user, increase the game difficulty in each level to make the game more entertaining and stimulating, and add silicone tiles to make it more user-friendly, as plastic tiles sometimes make it harder for the tactile sensor to work. Before starting, it was important to carry out some background research. Here are some key points. From a previous prototype, we found out that the circuitry is hard to fit inside the cube shell. There might be poor tactile sensor accuracy due to heating inside the cube and uneven encasing of the magnets, altering the Hall effect sensor reading for each tile. Also, there was a brief mention that the previous software implementation lacked complexity. I also found out there is a high demand for cognitive training tools. Although there is no concrete proof for long-term benefits for cognitive training yet, the short-term benefits seem to be appealing enough for people to invest in brain training. And finally, I established that making the game more engaging increased the user-perceived learning, therefore positively stimulating the user and encouraging them to interact with the game more. Before I started with the implementation process, it was important to set some training procedures at each step to minimize the likelihood of malfunctions and errors, making the implementation process efficient and cost-effective. Doing a continuity test checks for the physical damages to components. Then using some testing code ensures component compatibility and functionality. And more importantly, playing the game throughout the development process will help debug the system. And finally, after assembly, checking for component fit and proper installation reduces the chances of malfunctions. So, with all that in mind, let's get to the hardware implementation part of the project. So for the hardware, I use a custom PCB fitted with Hall effect sensors, RGB LEDs, and an analog to digital converter. The PCB lights up the tiles and detects user input through tactile sensors. Then I designed silicone molds to cure silicone buttons, which are custom designed for the tactile sensor, and address the sensitivity issues mentioned in the literature review, as silicone is more flexible. I also used two 7-segment displays to show the score and the high score, an itsy-bitsy microcontroller to code the system, and I 3D printed a cube skeleton. For the software implementation, I used the Arduino IDE, as the itsy-bitsy microcontroller is Arduino compatible. On the right side of the page, you can see the meaning of each tile color, which will be revisited later on in a demonstration of how the game actually works. For the software implementation, the crucial aspects were developing a game and increasing game complexity. The game complexity was improved by increasing the tile sequence as the user improves the recall abilities, also by increasing the speed at which each sequence is shown as the game progresses, and finally, providing feedback to the user by tracking and displaying the score and the high score. Finally, The last step of the implementation process is the integration of both software and hardware to make an embedded system. In order to do so, additional tools were used to alter the cube design and ensure the components were well insulated and fastened in place, making a robust system. Here's a short demo of the cube and how it works. Once the power is on, the tile immediately lights up the color blue. The first pattern consists of a 2-tile sequence. When the tile lights up orange, it indicates a fake tile that's not part of the sequence has been introduced. Therefore, you should avoid pressing it. After the sequence is complete, all the tiles will flash the color magenta to indicate the user input is required. After pressing each button, if the tile turns green, it indicates the correct tile part of the sequence has been pressed. However, if the tile turns red, it indicates a tile that's not part of the sequence has been pressed. If the user input is wrong, the score and the high score will be displayed and the game will reset. If the user input is correct, the game will continue and a new pattern with a higher sequence length will be displayed. The previous steps will be repeated while incrementing the score at each level. Additionally, the game will get increasingly more challenging as the sequence will be shown for a shorter period. It is also important to note, the game will only display a maximum of 50 tiles per sequence. The game continues forever unless the user presses the wrong tile, and the game will reset if the power supply is removed. Here are some of the main challenges faced during the design and implementation process. 3D modeling the mold was a very time-consuming task that I had no prior knowledge on how to use Fusion 360. This meant I had to develop mold prototypes and slowly refine the model. For example, I failed to realize that the mold lid does not have enough material to join the bottom part of the lid with the top. Therefore, once I printed the mold, the lid was detached at the bottom, and I had to superglue it together. However, I managed to solve the issue by redesigning the molds. Another obstacle was figuring out the optimal procedure and conditions to handle the silicone and cure. Because if the degassing process is not done correctly, it leads to air bubbles, which are both impractical and not aesthetically pleasing. However, the presence of air bubbles with the background research helped me realize the importance of having an air gap between the Hall effect sensor and the magnet to make the tactile sensor more sensitive. And finally, the biggest challenge was the debugging process of the PCB, as copper tracks were inefficiently designed and the PCBs were not manufactured by a PCB manufacturing company. This meant that there was copper residue between tracks that caused short circuits. Some tracks were too close to the edges, so they were broken. The via holes were too small and did not connect the PCB layers, and the tracks were too close to each other and passed underneath the components. Therefore, in order to debug the system, components had to be desoldered, making those components unusable after. However, this issue was solved by redesigning the PCB, where I removed unnecessary components and connections, rewired the copper tracks to allow enough space between the tracks, and moved the components around to make the soldering process easier. Finally, I doubled the size of the via holes to connect the PCB layers. So, now that we've seen how the system actually works, what are some of the improvements that we could make? Here are some suggestions. Firstly, we could use more components to make the cube multifunctional, therefore reaching a wider audience. Also, we could implement a rechargeable battery unit to make the cube fully portable, as currently it is confined by the reach of the micro USB cable. Also, we could design an internal shelving unit to organize the components inside the cube and the wires, preventing short circuits and making the system more robust. Finally, as the current system restarts every time the power supply is disrupted, it will be useful to use EEPROM memory to allow the user to resume the game. However, the EEPROM memory limits the life expectancy of a microcontroller. In conclusion, over the academic year, I was able to develop a fully functional prototype named the Unforgettable Cube. I was able to achieve all the software requirements, and due to some time constraint, I was not able to implement the battery for the hardware aspect. However, I was able to achieve my main objective, which was implementing tactile sensors in memory recall game and explore the uses of tactile sensors in gaming and gadget sectors. Thank you for listening.